Hello everybody. The topic of this section is multiple cash flows. So far, we have considered the situation in which there is a single cash flow in the future. What happens if there is more than one? In this section, we will discuss this question mainly. Let's consider an example. Suppose you are offered an opportunity to invest in a project that you need to pay $100 now. This project will pay you $20 a year from now, another $50 2 years from now, and then $60 in 3 years. The cash flows in this situation are more than one, and both cash outflows and cash inflows exist in this situation. In order to deal with some more complicated situations, a useful tool is introduced here. It's called timeline. Timeline is a diagram, which is a useful tool in analyzing the timing of cash flows. In the timeline, a negative sign in front of the cash flow means that you put in that amount of money or cash outflow from you, whereas no sign means that you take out that amount or cash inflow to you. In this example, you put in $100 at time 0, which means now, and take out $20 at the end of the first period, means the end of the first year, $50 at the end of the second, and $60 at the end of the third. Next, let's see the future value of a stream of cash flows. Suppose that each year you deposit $1,000 into an account paying an interest rate of 10% per year, starting immediately. How much will you have after 2 years if you do not withdraw any money before then? So the question is to calculate the total future value at the end of the second year. The timeline is drawn as follows. At the time 0, you deposit $1,000 into an account. So there is a $1,000 outflow from you, that is minus $1,000. And at the end of the first period, you add another $1,000 into this account. So there is another minus $1,000. We aim to calculate the total FV at the end of the second period. The $1,000 deposited at the time 0 grows to 1,000 multiplied 1 plus 10% to the second at the end of the second year. And another $1,000 added into this account at the end of the first year grows to 1,000 multiplied 1 plus 10% at the end of the second year. Adding the two FVs together, there is $2,310 in the account after 2 years. Let's do a quiz. Suppose you deposit $1,000 now and then $2,000 a year from now. How much will you have 2 years from now if the interest rate is 10% per year? By the timeline, at time 0, there is a $1,000 outflow from you. And at the end of the first period, there is another $2,000 outflow. At the end of the second year, the $1,000 deposited at the time 0 grows to 1,000 multiplied 1 plus 10% to the second, and another $2,000 deposited at the end of the first year grows to 2,000 multiplied 1 plus 10%. Adding the two FVs together, you will have $3,430 after 2 years. Often, we need to compute the present value rather than the future value of a series of cash flows. For example, suppose that you want to have $1,000 1 year from now and then $2,000 in 2 years. If the interest rate is 10% per year, how much would you have to put into an account today in order to satisfy your requirement? In the timeline, at the end of the first period, there is $1,000 cash inflow to you, and at the end of the second period, there is another $2,000 cash inflow to you. We need to calculate the cash outflow at the time 0. The PV of the $1,000 you will get at the end of the first year is equal to 1,000 over 1 plus 10%. The PV of the $2,000 you will get at the end of the second year is equal to 2,000 over 1 plus 10% to the second year. And adding the two PVs together, the cash you need to put into the account is $2,562. Finally, let's see the investing with multiple cash flows. Suppose you are offered an opportunity to invest in a project that will pay you $1,000 a year from now and another $2,000 2 years from now. The project requires you to invest $2,500 now. You are convinced that the project is completely free of risk. Is it a worthwhile investment if you can earn 10% per year on your money by leaving it in the bank? The cash flows in this project are depicted in the following timeline, which is resemblance to the previous one. $1,000 inflow a year from now and $2,000 inflow 2 years from now. If you put your money in the bank, it would take $2,562 to generate the same future cash flows in the project. The NPV is equal to the PV in the bank, $2,562 minus the PV of the project, $2,500, is $62. It's positive. By the NPV rule, this project is a worthwhile investment. In summary, we have discussed the calculations of future value FV and the present value PV for the multiple cash flows in this section. That's all about this section. Bye.